Hello and welcome. My name is Deborah Rowe, and I'm here to tell you about the wonderful world of heat pumps and what it can do to help our economy and our environment and your careers and how you heat and cool at home. So let's get started. What is a heat pump? Well, a heat pump is something that can help you bring in heat from the inside and send it to the outside. So in the summertime, you can be cooler, just like an air conditioner works. A heat pump can also take heat from the outside, even though it's at cold temperatures, and pressurize it and bring it inside so that it can help heat your home in the winter. So a heat pump can do both. It's very versatile, using the same kind of technology we use in our air conditioners and refrigerators today, but in a more sophisticated way. Heat pumps do not generate heat. They move it from one setting to another. Where does the heat come from? Well, in the heating mode, the heat comes from the sun, and the sun heats up the outdoors, and with some electricity to pressurize that refrigerant inside the heat pump, we can take that heat from the sun, bring it into the house, and pump it inside at temperatures that are useful to us. In the cooling mode, we can take heat from the inside and pump it outside with a little bit of electricity, and you get really good performance with the heat pumps that are on the market today. How do they work? This refrigerant I've been talking about is pumped from the inside to the outside, back to the inside. And when it's pressurized, it delivers heat at higher temperatures. And when it's depressurized, it can collect heat at lower temperatures, like here you see in the wintertime mode and the heating mode. Now, in the cooling mode, what happens is you have the same pumped refrigerant, but in this case, it collects heat in a depressurized mode from inside the house and delivers it outside, thereby cooling your house like an air conditioner. What are the customer benefits from using heat pumps? Well, you can save money on your costs, on your utility bills. You can stabilize the costs that you have. You don't have to worry about costs going up and increasing your bills because you are utilizing electricity. And sometimes you can provide that electricity with renewable energies that are either on site or coming from the grid. You can add cooling to spaces that don't have cooling, that only have heating. You can provide increased control and capacity with this, using it as supplemental equipment. And you can avoid the risks from having combustion heating in your home. Also, there's a great interest now in the country and around the world in slowing climate change. And heat pumps are very helpful with slowing climate change because it allows you to use electricity, and that electricity can come from clean energy like solar and wind. And heat pumps also allow you to take advantage of efficiency improvements. Excuse me. So heat pumps, what are the market trends? What's going on out there? We're seeing a national trend towards electrifying buildings. The electric grid is getting cleaner. We're switching from fossil fuels to electricity that allows homes to lower their climate and pollution impacts by using electricity that comes from renewable energies, like I already mentioned, wind energy and solar energy. Also, heat pumps are significantly more energy efficient, and just their efficiency is higher than fossil fuel systems like natural gas furnaces. Also, it allows you to add air conditioning, and we now have this breakthrough in the market, which is cold climate heat pumps. It used to be that heat pumps couldn't work well in cold climates, but the technology has improved, and now it's a possibility in lots of places where it wasn't before. So what are the advantages of adding heat pumps if you're a heating and cooling business owner? Well, it offers the opportunities to increase your sales and also, of course, increase maintenance opportunities for customers that have heat pumps. Any HVAC equipment needs to be serviced, and this does too. Some customers will tend to use dual systems, which means they'll have both the furnace and the heat pump. That way the heat pump doesn't have to be as large and your supplemental heat might be more cost effective. That gives you a couple of systems that you can help the homeowner maintain. And because of these cold climate heat pumps, you now have a way to offer them as a product in the northern parts of the United States. And that can give you additional sales while helping your customer at the same time. There are lots of job opportunities in this, right? This increased demand for heat pumps is resulting in more kinds of jobs like sales, design, installation, maintenance, manufacturing, education, and more. Now, air source heat pumps, that's what ASHP is. Air source heat pumps have operating costs that actually can be lower, can help you save money on utility bills. And it varies from household to household. But here's one example of where the proposed annual heating costs with the heat pump actually will save $100 a year over the gas furnace. And I'm not going to take the time to go through the calculations, but it's a pretty fun thing to understand. So the components of the heat pump are a condenser, a compressor, an evaporator, and as you can see here, it's covered up, so I'm going to make it an electronic expansion valve. And so depending on the mode that you're in, this is the heating mode. So what happens is it picks up heat from the outside, and then it's brought into the home through a compressor. So it's cold outside in the wintertime, right? So the temperatures are lower, but the compressor, by pressurizing it, brings those temperatures to higher levels that are useful in the home for heating. And then it gets released inside through the condenser. And then an electronic expansion valve depressurizes again so that you can go get more heat from the out of doors, even though it's cold outdoors. And then we know that traditional heat pumps, the ones that used to be on the market, didn't do well at low temperatures. But the ones we have now can do quite well at low temperatures, meaning that cold climate heat pumps require a lot less supplemental heat, making them more cost effective. So, anytime you put in a heating and cooling system, there's going to be this opportunity to design it, right? Some choices that have to be made. And so you could become a designer and you can understand the difference, air source heat pump designs and the intentions of the homeowner and of the contractor. And you can learn the different design options, and then you can help design. Each house is a little different. And just like with any heating and cooling equipment, we want to customize it to the needs for the customer. So you've got to decide, what are you going to do? Are you going to only heat a portion of the home or only serve a portion of the heating needs? Are you going to have supplemental heat, or are you going to size your system so it heats the entire home at full load and you don't really have to have a backup? You have to make decisions about, are you going to split it into zones, each with their own heating system? Or are you going to control the zones with their own thermostats? And if you have larger buildings or homes, this can make a lot of sense. Or are you going to try and do a whole house system? And this works well if you have ducts to take the energy from one place to another. It works well with smaller homes. And then you can decide, do I want a system that has ducts that takes it from one room to another? Or do I want to have the systems that are ductless, that are just based in each area where you want to heat? So lots of fun choices that you have. Bottom line, you can be a clean energy hero, either by buying a heat pump and using it, and or have a career in the wonderful field of heat pumps, particularly cold climate heat pumps, but also in very warm areas too that need a lot of air conditioning, and in moderate areas. The whole country can benefit by the use of heat pumps that are powered with clean energy, like electricity from solar energy and wind power. This is our future. Be a part of it. Thank you.